Under a roof that swallows whole wings, lights buzz and hoists drift overhead, while a fuselage section hangs, waiting to meet the airframe below. Inside a building this big, precision fights drift. Temperature, floor vibration, and fatigue can nudge alignment off true, and one crooked joint can ripple through the structure. So crews align in jigs, fastened by torquey sequence, and dock modules from above. Fixtures, hoists, and voices acting as one machine. Miss a seal or land a module out of true and rework multiplies. Power on checks won't pass. Schedules won't move. What is the exact sequence, from alignment calls to docking to first power-up, that keeps this line on target? The mission sounds simple and is anything but. Turn delivered structures and systems into a safe, certifiable aircraft through repeatable steps. Operators place and connect. Inspectors prove conformance. Test crews bring the machine to life in layers. One principle governs the floor: throughput without surrendering conformance. Two stakes drive every decision. Technical: fasteners must clamp, seals must hold, linkages must move, data paths must communicate. Each step has to meet its acceptance criteria. Schedule: units must advance when the line advances. Hold one aircraft too long and upstream, staging chokes while downstream stations idle. Positions must be trusted before the first fastener turns. Next, the measurement discipline that makes alignment real on a building scale floor. Alignment here is physical, audible, and shared. As a component approaches a jig, calls step down from coarse to fine. Over, hold, then tiny nudges onto centerline and hardpoints. You hear distance cues shrink until the part settles like a lid onto a box you can't afford to scratch. Distance callouts ratchet from centimeter guidance to millimeter nudges as the fit closes. That cadence is the measurement system, tools plus coordinated human sensing. Even smaller subassemblies get the same treatment. Pylons are eased in with distance calls that prevent binding at their interfaces. A micro reveal, a quick handheld laser shot across two reference targets, catches subtle yaw drift that voices alone might miss. If calls are wrong, holes won't match, seal paths won't sit, and a forced fit hides stress you'll pay for later. Positions verified. Next, how do they lock the structure without freezing distortion into it? Design logic: the system diagram in words. Think in 3 layers. Primary structure carries load. Systems, hydraulic, electrical, data move power and information. The envelope, skins and panels, seals, smooths airflow, and preserves access. Interfaces are where errors travel. Purpose arrow constraint, arrow solution, arrow consequence. A skin-to-skin seam must stay flush for airflow and maintenance. Temperature and clamp force can make it creep. Controlled torque, adhesive/seal timing, and inspectable fastener rows hold it. If it lifts or waves, you invite drag, leaks, and future teardowns. Motion paths are proven early. Hinge lines and seam clearances are checked, so moving surfaces run clean under load. Governing principle: throughput with conformance. Design for verification means joints you can see, systems you can isolate, and steps you can sign off before panels close. To run those checks at speed, you need a sight inside the site, lanes, staging, and controlled movement, which is what they build next. Before assembly flows, the floor becomes an engineered work site, painted lanes for transport, marked exclusion zones, and hold points before any lift. Inside a live line, access is a safety system. Movement is choreographed. Crews call their station passes so heavy parts don't surprise people and tools in active zones. A stabilizer or similar surface is only cleared for internal transport after a gate check declares it safe to move without stressing its attach points. One simple gate protects crane windows. A pin count and latch torque read at the cart before the rigging team is even called. Miss it and the lift is scrubbed until the numbers are right. Pre-staging keeps tempo. Hardware arrives kitted to the lift, so installers can move from placement to connection without hunting parts. All that movement only works if the jigs and floor behave. How do they prove the base stays true under load? Foundation/anchoring/ground improvement. Here, foundation means how fixtures send forces into the slab without distorting the airframe. Jigs don't just hold parts, they define geometry. As clamps pull joints and tools torque fasteners, loads must flow through hold-downs and datum frames that don't budge. So crews validate the base under both zero load and working load, logging that hold-downs and datum points Hold position as torque rises. If the base moves, the alignment above is fiction. Risk, vivid and costly. A slab that creeps during a lift walks bolt patterns off their marks. The fastener that should slide fights back. Now you're reaming, shimming, resealing, and documenting every deviation. Small reward. A mid-shift jig recalibration catches a tiny drift and prevents a round of hole reaming downstream. With the base behaving, the line can run the repeatable cycle that builds most of the airplane. Core build sequence, vertical/linear/planar. Set out, reference marks aligned to jig datums. Teams guide the approach from coarse to fine until the part kisses the hard points. Place. The component settles under controlled cues. Hold, down to, touch, until the geometry is captured. Fasten, sequenced. Key fasteners seat first to share load, then the joint walks out in a planned pattern. A small, surprising step. The tool goes to hand torque at first bite so a mechanic can feel seat and thread engagement before any power torque is allowed. A torque value is called and logged before the team advances. Connect systems, actuators, brackets, and linkages secure in order, each tagged and called complete. Hydraulics follow with a clear-to-connect call, pin set, and clamp closure, freezing the connection into the record. Batch by zones, a row completes, creating a natural verification gate, inspect, sign, then proceed. Verify motion, moving surfaces cycle. Reports of nominal travel confirm hinges, linkages, and clearances work as a system. All of this has to survive the dock. The crane won't hide misalignment. Signature operation, the impossible moment. Step by step, with the risk turned up. Pre-lift, latch integrity and attach points are verified. Only then is the module cleared for hoist. Approach. Spotters call remaining distance while riggers trim taglines to kill sway. The crane inches in with lift-hold-nudge moves rather than forcing contact. Contact and capture. The structure finds its references. A lock confirmation at a defined rib station is called from the airframe side, proving engagement at a known structural index. A quiet, telling hold point. A shim check slides clean with a faint click that confirms gap control before any torque clamps it shut. Seating, module seated, is declared only when all attach points show engagement, preventing partial contact from tricking sensors. Where external hardware is involved, placement and torque are verified before any lift that would hide the joint. Control system in one line. Sensors watch position and attitude. Hold points, gate progress, go/no-go limits, bound movement, and if readings drift, rollback is the rule. Stop, back off, re-rig. Metal is down. Now the invisible work begins. Seals, hidden fasteners, and data paths must be proven before power touches the airplane. The line runs on choreography, not chaos. Large assemblies travel internally as cleared packages, reducing line-side work when access is tight. Crews call station markers during movement, so nearby teams can secure tools and safeties. Trade-off, crisp. The more you pre-assemble upstream, the cleaner the dock, at the cost of tighter scheduling and coordination to feed the hoists on time. A small reveal, each incoming module carries a kitting checklist with a tamper-evident seal. At arrival, the lead signs it before the first sling goes tight. Next consequence, if it isn't proven, it doesn't join. Enter the quality gates. Safety, quality, and verification gates progress is what you can prove. Inspections run in layers. Visual checks on coatings at accessible points before closeout, alignment and seam checks where airflow and access depend on fit, and functional verifications on data ports before any power on. Pressure and load tests gate systems. Teams watch readings, stabilize within defined thresholds before sign-off. Traceability binds it together. Tags, batches, signatures, timestamps. Concrete catch and fix. A torque log flags an under-torqued fastener. The joint is open, threads inspected, sealant restored, torque reapplied and relogged before closeout. Next step is controlled and irreversible in a new way. Staged power-up, but only after comms are clean and isolation checks pass. Systems integration, MEP/controls/operations. Integration follows a three-step flow. Connect data, verify communications end-to-end so the aircraft can talk to itself and the line. Apply shore power, ground power connects and stabilizes, feeding initial checks without lighting engines. Run layered functions. Lighting sequences, proof circuits, and indications. Redundancy exercises follow. Switch power buses. Prove the system stays up when you isolate a path. Pass/fail criteria are enunciations that must remain stable through the switch. Open loop to engines. Spool only when landing gear locks are verified. Power buses are green. Fuel isolation is proven. And environmental limits are within range. Commissioning, testing, and first-run commissioning moves from quiet checks to controlled motion. Pre-dynamic locks. Landing gear pins and down locks are verified to prevent collapse during tests. Engine spool and idle monitoring. Ignition arms. Parameters rise to planned idle under strict watch. Any drift outside limits in the sequence pauses. Post-run, taxi, and surface checks follow only after greens across systems, with every indication logged for analysis. A small first-run adjustment might be a trim tweak or a software parameter update, then a retest to confirm the change. The rhythm from here is disciplined and repeatable. Measure, align, connect, prove. One certified aircraft at a time.